Hi, today I'm going to go through PAT 2016 paper looking at question 9. So question 9 asks us to solve 5 minus 3x is strictly less than 2 over x. Okay, so we should be familiar with these by now. And what we do is we know that if we multiply, we remember that if we multiply both sides of the inequality by a number, we have to be sure that it's positive. Otherwise the inequality sign could switch. So what we're going to do is we're going to multiply through by x squared, because we know that x squared is positive. So multiplying through by x squared, we get 5 minus 3x times x squared is strictly less than 2 times x squared over x, or 2x. And therefore 5x squared minus 3x cubed is strictly less than 2x, or 3x cubed minus 5x squared plus 2x is strictly positive. Okay, well somehow we need to find values of x for which it's going to work. And what a hint will be, this is a non-calculator paper, and so we're going to presume that it has nice roots. So we're going to let f of x equal to 3x cubed minus 5x squared plus 2x. And when we notice that that factors to 3x squared minus 5x plus 2. And what that is equal to, we see that factors into 3x minus 2 times x minus 1. And well, if you want to do a trick of how you can spot that quickly, you know that you have these two constant terms and multipliers give you 2. So that's going to be either a plus 2 and a plus 1, or a minus 2 and a minus 1. And since you have a minus 5, we're going to presume it's minus 2 and minus 1. And as 3 is prime, we have to have a 3 and a 1 in front of the x. And so we just test out the possibilities, and this is what the answer is. So we require this to be strictly positive. Okay, so let's sketch this graph down. So we're going to sketch f of x against x. Well, we know it has a root at 0, a root at 2/3, and a root at 1. So this is going to be 2/3, this is going to be 1, this is going to be 0. And we know it's a cubic, so we know it's going to come up like so, come down through here, and then back up like that. So when is that strictly greater than 0? Well, we see that's going to correspond to this region here and this region here. So we get that x has to be, well, this one here is between 0 and 2/3, so strictly greater than 0, but strictly less than 2/3, or x is strictly greater than 1.